Greetings to all and welcome to the next video tutorial of the playlist Abaqus. In previous video tutorial we talked about the nonlinear analysis and linear analysis. So basically we talked about material geometry and contact nonlinearity, and we seen how results are affected by assuming the nonlinear parameters. Those are the material parameter or maybe the geometric nonlinearity. So in this video tutorial we will see how to perform such nonlinear analysis in Abaqus standard, and we also see what type of problem we are facing during the analysis. It's not so much straightforward as we perform the linear perturbation analysis if we have the large deformation condition. So we will see if there is any issue in the convergence, so why this problem arises and how can we overcome with such issues. So let's start with Abaqus environment, and here you can see the plate component I already created to save the time. So after creating the plate component or any part, you have to go for here properties. Just go for property and go for create property material. Actually by material manager, these things are nothing but your managers, and I always prefer to go for manager, because if you have multiple entities like multiple material, multiple sections, then things are quite easy to handle with manager. So just go for create here material, any name you can decide, general, density. So my unit are here mm, ton and seconds, so density will be 7800 e raised to the power minus 9. Okay, after defining the density, just go for mechanical properties, elastic. For defining the linear material, I need to define the elastic properties. So the Young's modulus will be 210 e raised to the power 3 and the Poisson's ratio 0.3. Just hit on OK button. I don't need to define the plasticity parameter for the linear material case. For the first case, I am taking linear material as well as geometric linearity, and we will compare those linear results with respect to the non-linear one. So here now go for, either you can dismiss this or you can keep it okay, and section manager, go for create section. So this is the plate component, and for that I have to create cell, homogeneous and section, any name you can define. Go for continue. Okay, define here the thickness value. For my plate I am taking the thickness value 1 mm only. Whatever the material you decided previously, it will be automatically selected, or if you have number of material you can select from the playlist. Okay, this is the thickness integration rule and number of integration element along the thickness. In my previous videos I already talked about the integration point. That video is available by named as hourglass and shear locking, where we have integration point on the element as well as we have integration point along the thickness also for the 2D element case. So those things are nothing but your integration point along the thickness. Okay, so we will not discuss too much on that. Just go for OK, dismiss, and then go for assign the property, and here again go for create, select the plate. Okay, if you don't want to create any set for the whole plate component, just go for uncheck it, otherwise you can keep that checked on. Done, and whatever the property you created, section you created, that will be here, and just hit on OK button. If the property is assigned, the color of the component will be changed, you can see here. So after deciding property, you have to go for an assembly environment. Just go for here create instance and select the plate component. You have to go for dependent or independent component. I already explained those things also, dependent and independent component, in my previous video. If you still confused about the dependent and independent part, you can go for that video. The link will be available in description. So just go for here independent part and click on OK button. So this plate is now in the assembly mode. Okay, after assembly you have to define the step. In Abaqus the things are quite easy. See here in the module all things are available, so you have to go for sequentially. Okay, sometimes you may break the sequence, but most of the time you can go for sequence and perform the simulation. So in this case I have to define the step. Just go for here step manager. The initial step will be always created here, and you have to go for create your own step. And as I told you, we are going to use the Abaqus standard general static analysis for the linear and non-linear case. Here we have perturbation scheme also. In future videos, we will talk on the difference between general static and linear perturbation steps or procedures. So right now I'm going to define here general static. Just go for continue. Okay. Any description if you want to define. The most important thing that we have to decide here, geometric nonlinearity, check on or check off. So as I told you, this is the initial linear analysis. I am not going to define geometric as well as material nonlinearity. So just keep it off. Go for incrementation here. The total time period is 1 second. Go for incrementation, and this is the initial size that we are suggesting to the software. So 0.1 is quite sufficient for linear analysis, because in linear analysis there is no issue for convergence. And the maximum increment size also I am going to define as 0.1. So we will talk on this also, increment size, in this video itself. So don't worry about those. And the total number of increment that I am allowing is 100 to perform the simulation. If my simulation go beyond the 100 increments, it will be abort the process. And keeping the all parameters as it is in the other tab, I'm not going to talk on those parameters, but we will talk on those also in future videos. Just go for OK. Once step is decided, you can go for create your interaction, means contact, if you have contacts in your model. After that you have to go for define the load. But what I suggest, before defining the load, you have to go for the mesh. So let me go for define the mesh. Why? Because sometimes we need to apply load on the nodal positions. So if we have meshing, then we can easily decide the load or boundary conditions on the nodes. Okay. And in the meshing, first thing that you have to decide is element type. What type of element you want. I am going to define here by this icon, element type. Okay. So Abaqus standard linear element I want to define, and here you can see family, the cell element family I am going to define. Next I am going to define the reduced integration scheme. Why I am going to define reduced integration scheme? If still you are confusion about that reduced integration and full integration, again you have to check my previous video named as hourglass and shear locking. I talked on the same thing. Other element control I am keeping as it, and just go for OK. Next thing you have to define element control. So just go for this icon, mesh control. Yeah, here I want the structure mesh for the component, and just go for structure. And the most important thing, I need only the quad element. Okay, so quad structure, and just hit on the OK button. If you use the dependent part, then you have to go for part instead of assembly during the meshing environment. Next you have to define element size, or you can say seeding value. So I'm going to define here element size 4. Just go for apply and OK button, and now just go for mesh. So go for here in the first options and hit on the yes. So this mesh is created, and again now go for the create the loads. Before creating load, I am going to create some sets to define the constraint and force appropriately. So either you can go for in assembly and just click on sets here, just double click on that, and sets of what? Nodes. The set 1 instead of set 1 I am going to define as constraint 1. Two constraint we have in the model, and it is asking for the nodes. I am going to select these nodes. Okay, these nodes are highlighted, and then again double click on the set component and go for define second set as constraint 2 by using nodes. Continue. Basically this plate I am going to bend about this y-axis. Okay, this y-axis. Here I am going to constraint, and here I am going to apply some load, and as well as I am going to constrain from here also, that bending will be take place properly. Okay, so just go for select some node here, likewise Yeah, there is no experimental data available for the plate component. Only we want to learn the difference between linear and non-linear analysis. So just randomly I choose the nodes for the set. Otherwise you can split your geometry and select node properly. Okay, just click on done. So 2 sets are created. Again one more set I want to create by named as force node continue, and these nodes I'm going to choose. Just done. Okay, now go for here load manager, create load. So basically I'm going to create a concentrate force on these nodes by help of sets. So mechanical concentrate load continue. If you have already available sets, just click on that sets button, force, and check on these options. Those nodes will be highlighted. Continue. Yeah. Here the load direction is C, positive Z. So just go for define here value 3 unit. By default Abaqus use the ramped type of load. Just keep it in mind, we will talk on that in the nonlinear analysis. Even if you go for the follow nodal rotation, it will not useful here because we are performing the geometric linear analysis. Okay, so I'm going to uncheck this. Okay, yeah, load is created. Next go for create the constraints. Constraint manager, create. First constraint that I want to create here encaster, or you can say fix. So just go for here axis symmetric encaster, select the set, continue, and at the last you have encaster options. Okay, and again second load I want to create, that should be allow the rotation but should not allow the translation. So instead of going to encaster, you have to go for define the displacement rotation. So just go for displacement rotation and constraint 2, continue. Yeah, displacement along x direction I'm allowing because that may stretch during the bending. Okay, but displacement in second and third direction I'm not going to allow. So just constraint it and click on the OK button. Okay, constraints also created. Go for dismiss, and now just go for defining the job. Just go for here define job manager, create. So job 1 linear analysis, I'm going to define name as a LA linear analysis model 1, in which we have our geometry, meshing and boundary conditions. Just go for continue. If you want to define number of parallel processing, or you can say multiple processors, you can go for using this parallelization options. So in my case I'm going to define the 12 processors and go for OK. Make sure you save your file, and the most important thing, make sure your working directory should be same where your model is saved. Why? Because if your working directory will be different, what will happen? Your animation files and other important files will be created in somewhere in temporary folder. Okay, we don't want, we want to create the all files in a single folder. So to do so, you have to go for define working directory. So in Abaqus I have nonlinear analysis folder, and this was my folder. So same folder I am going to select as a working directory. OK and OK. Please make sure this working directory options. Okay, and go for data check, and you can go for monitor also. If there is no error, then it will be show as a successfully complete options. Okay, see here also you can see. Okay, now you can submit your file. Just go for submit and OK button. Just go for monitor. So this is the linear analysis, geometric as well as material linear. There will be no difficulty in the convergence of the problem. So see, even in the matter of seconds the problem is solved, and these things are nothing but your increments, attempts made for convergence in the increment, and here we have the total time, and here at last we have the step time. So maximum step time we decided is 0.1, and the initial time step also we decided 0.1. So software easily get converged by the initial time step that we decided. So just go for dismiss and click on the result button and click on this options, deform shape. The most important thing, the deformation, if you go for here, the deformation value u, the deformation is quite high, but it is not visible. Why? Because of the scale factor. So just go for here in the common options, and here you have deformation scale factor, uniform, and the value should be 1. Apply and OK. So go for some standard view, that will be more visible. Likewise. Even you can go for selecting the third options, press and hold on this icon and use the third options. So deform and undeform mode will be visible here. See, in the linear analysis, whatever the deformation is there, the initial node position and final node position of the element always be in a line. Okay, it will never rotate. The load will never follow the deformation. But that is not real case. If you want to animate, just go for animate. Okay, likewise. So now what I want to perform nonlinear analysis, geometric nonlinear analysis. So very few changes I have to make here, and just go for step. And before going to change in step, let me save the file first in the original folder, and second I'm going to define file in new folder, and that folder name I'm going to define as 02 and geometric nonlinear. Okay, so geometric nonlinear, go for OK and save your file here. And after saving file, make sure the working directory should be changed, set work directory. Otherwise what will happen, whatever the simulation you are going to perform, that will be overlap in the previous folder. So just go for here, selecting second folder as a working directory. Okay, so what you have to do, you have to make change only in the step. You have to go for check on the nonlinear geometry options, and second most important thing, you have to make change in the loads also. In the load I have to go for here, check on the follow nodal rotation options and go for dismiss. Save your file, go for job options and submit your analysis. No need to check data again and again because we know our data is correct. So just go for monitor here. See, the deformation is quite large here. Okay, initially Abaqus standard able to get converged, but after the large deformation maybe there's some problem. Okay, to make converge, it going to be decrease the incrementation time. See, you can see initially analysis is successfully completed. Initially we decide the incrementation as 0.1, and at the second increment itself software is unable to attempt equilibrium, or we say we did not get convergence. So what software did, it just reduced the step time, okay, till we not get the convergence, and continue the process. Go for dismisses and result. Again go for deform and undeform mode, just hit on the some standard view. So this is my nonlinear analysis result, and if you want to open the linear analysis result also, just go for this window, create viewport, and here I am going to open the previous result that already we have here. Okay, so just double click on that and go for some standard view again and deform and undeform mode, and click on the tile options. So see, this is my nonlinear analysis and this is my linear analysis. And if I go for play the both, let me make it more wider, and here also I have to animate. So see, in the nonlinear analysis, load is following the rotation path you can see here. Okay, and in linear analysis load is not going to follow deformation. So just make on last step and you can see a clear difference between them. And another most important thing, here we have the stress value is around 1082 megapascal. For such bending of the plate, such high stresses is not possible. These results are faulty, and in the previous video tutorial, linear and nonlinear analysis, I already discussed on those, why those faulty results are appear because of the wrong selection of the material, or we can say we did not select the nonlinear material for the high stresses, or we can say if we are working the beyond yield point, we have to select the material non-linearity. So to do so, I am going to define non-linear material. So for defining the non-linear material, you have to go for the property. One more thing, I am just going to save the file in current folder, and new file I am going to save. The same file I am going to save in new folder, and here the material non-linearity. Let's go for OK. As well as I need to save the working directory, this third folder. Okay. So just click on the material manager and edit the material, steel material. I am going to delete the elastic parameter, and I am going to define the deformation plasticity material parameters. Here I have to decide the Young's modulus, that Young's modulus same as linear material, 210 e raised to the power 3, e raised to the power 3. Poisson's ratio is 0.3, that is the yield stress is around 180 megapascal, and exponent, generally what we seen that exponent value is varying from 0 to 1, but here the material formulation is something different, and that exponent value is recommended by the Abaqus should be greater than 1. Okay, and it is recommended if you don't have exponent, you have to use the approximate value 5. Okay, so I don't have such material, and I'm going to use that exponent value as 5, and yield offset 0.2% I'm going to choose. So now the nonlinear material is defined according to those parameters. Just hit on the OK button. Yeah, geometric nonlinearity we already selected, so we just go for selecting the nonlinear material and go for creating a job. Delete this existing job, or you can simulate with same job, but I'm going to delete now because I want to rename the job. Here the job 3 material nonlinearity. Okay, make sure in the job there should not be gap, okay, between the name. Continue, and parallelization, number of processors. Again hit on the submit button and go for monitor. Here the monitoring is very important. Why? We will see, because in this case we have geometric nonlinearity and material nonlinearity, so there are most of the chances that convergence will not occur. If the convergence is not occur, we will look what problem we are facing in the convergence, and what is the solution, how we can get converge the solution. It is always recommended that for the excessive large deformation is different thing. For the excessive large deformation, you have to go for dynamic analysis, explicit implicit analysis. But here we have very large deformation, as you seen in the previous animations. But still we are performing the simulation by using of Abaqus standards. So let me see, is it converged or not. Okay, analysis is finished with one termination error. The maximum number of increments are, we defined only 100, and it need more increment because the time step is very small here. Why? Because software are trying to converge the solution by reducing the time step. Okay, see, the time step is going to continue decreasing. Somewhere it is going to increasing also. We will see why it is. So let me increase first the, go for edit, For safe side, I am going to define here 2000 increment because for such highly nonlinear analysis there will be very small time increment and software may not converge the solution. And another most important thing, initial increment size that we are suggest to the software is 0.01. I am defining. Okay, now again save the file and run the simulation. So again the simulation is finished with error message, and the termination in this case is due to the minimum increment size that software achieved, 1 e raised to the power minus 5, and we decided the minimum increment time is 1 e raised to the power minus 5. Even such large deformation cases with the geometric nonlinearity and material nonlinearity is very difficult to converge here. So why this is not going to converge, and if it is not going to converge, is it possible to converge the solution in Abaqus standard, and what are the causes and how to overcome with such convergence issue? We will see those all things in the next video. So in this video tutorial, that's all, and thank you for listening. If till now you not gone through my previous videos, the difference between linear and non-linear analysis, you can hit on the given link on the screen. It is very recommended to go with those videos before performing the simulation. Thank you again.